All right, thank you all for coming, even though it's the morning slot, although it's not morning for me, so it's kind of weird. I'm here to talk about spicing up your app with 3D, using a library I've been writing or porting recently called GThree. Let me see here. So GThree, it's basically a library that you can use to render 3D scenes. And it's even though it's not necessarily dependent on GTK, it's meant to work in the GTK and the GNOME frameworks. It's really a port of the JavaScript library thee.js, which I guess some people already are aware of. It ports all the JavaScript from or to C, and then JavaScript uses WebGL, but we port it to OpenGL, which is more or less the same, right? So, but huge chunks of thee.js is actually written in GLSL, which is the GPU programming language, and that uses it's used the same in WebGL and OpenGL. So we can basically reuse all of that. So a very large part of thee.js we can just lift in entirely. And design-wise, it's not a game engine. I mean, you can write games in it, but it doesn't have all the infrastructure that a game engine has. It's more like a low-level bag of bits that you can connect to make things happen in a much more flexible, but also less finished way. So it lives in the GNOME ecosystem, as I said. We have gobject as a base, so it's introspectable and should be usable from whatever language that you had that had bindings. It uses OpenGL for rendering, and it uses the graphene library by Emanuele for 3D mats, vectors, matrices, all of that stuff. This is used by GTK4 now, so these are all like core GNOME dependencies. It doesn't directly depend on GTK, but it has this extra library that you use when you want to use it with a particular version of GTK. So we support both GTK3 and GTK4. I mean, in theory, you could also use it without GTK, but then you have to do some hookup to get the basics OpenGL integration working. 3D is all about rendering something called the scene graph. And the scene graph that describes a hierarchy of objects in 3D, like they're three-dimensional objects put in 3 dimension. This is very much like the widget hierarchy in like a GTK layout, only it's in 3D. And the equivalent of a widget is an object, a GThree object, which is a base class that defines the child parent hierarchy, and it also has a transform. So every object transforms itself and its children just recursively. So like the outermost thing affect all the things inside it, which then can have further transforms. There are also some structural types like GThree group, which is kind of like a GTK container, in that it doesn't really do anything. It just groups things together, so you can transform them and refer to them as one. We have a scene object, which is basically a group, but it has some extra properties that are used for the root object, such as background color and things like that. You can actually have a scene object wherever you want, but it's only useful, or the scene specific properties are only used if it's the root in the hierarchy. Then you need some kind of visible object, something interesting to render in your scene graph, and these are the things we have. Mesh is the most commonly used one. It's the set of triangles that get rendered in some way. That's the most common thing to render 3D stuff. It's meshes of triangles. But we have lines and sprites and points. Sprites are being like two-dimensional billboard-like things in 3 dimensions. Once you have all the stuff you want to render in a scene graph, you want to use a camera to specify a view into the scene. This is where things differ from like a GTK hierarchy. There you like have only one way to view this thing, but rather here you can have multiple cameras pointing at in from different places into different directions inside the scene. And a camera object, or a camera type, the camera type is a GThree object, so you can put it in the scene, which can be useful. If you like have a car in your scene, you can put the camera inside the car, and as you drive the car around, the camera that is in there will see what the person inside the car would see, right? So, and the camera is a base class, and we have different types of cameras. The perspective one is the most commonly used one, because it has like a traditional perspective view where things that are far from the camera are small and the things that are close to you are big. Whereas the orthographic one is more like an engineering style, non-perspective correct view. Most objects render as dark if you don't do anything by default, because they need light to be visible. So we have light objects that you need to put in your scene in the places where you want them to be. And this will affect the things that are close to them. So by lighting up nearby objects, and also optionally, lights can cause objects to throw shadows on other objects. But that is kind of expensive, so it's not on by default. You need to like set up which objects throw shadow and which lights throw shadow. But we have a base class here, GThree light, which defines some basic property like color and intensity. And then we have different types of subclasses where ambient is a global lighting that affects everything equally, which you probably want. You want to have some ambient light so that things aren't completely dark. And then you add point and spotlights for specific lighting. Like a point light is kind of like a light bulb, whereas a spotlight is like a spotlight, right? It has a direction and like a cone of light. And these are more like sunlight and sky ground kind of lighting. And once you have these, a camera and a scene, you put them in a GThree area, which is actually a subclass of GTK-GL area, the GTK OpenGL widget. And it creates this renderer object, which is the main rendering object. It's more like an internal object, but it's what tracks all the state and stuff that we need to do in OpenGL. And in the default implementation of the render signal in the area uses this renderer to draw this particular scene from this particular camera. And most of the time, that's all you need. But if you want to do something else, maybe you have a multi-scene rendering, or maybe you have some kind of effect you want to apply, then you can override this render object or render signal and do something else. Yeah. Another important thing to have is textures. Textures is the GThree representation of image data. It's kind of like a pixbuff, really, but it's on the GPU. It refers to something on the GPU, right? Most images are 2D, but we also have 3D textures like cube textures, where you basically define the sixth side of a cube, and that defines like a three-dimensional thing. So if you're in the middle of the cube, you can look in any direction and there's a color. That's the 3D kind of texturing. Like from a single point, there's always in any direction some color value. And the most commonly thing that you use with these textures is color mapping using UV mapping, where you define UV coordinates for every point, and we interpolate these coordinates over the triangles, and we read the color from the texture and use that as the color of that pixel. But we can also do all sorts of more complicated mappings, like normal mappings, where we interpret the image data as vectors that perturb the normal of the surface, so we can create like small scale changes in surface geometry, kind of like sometimes it's called bump mapping, where you can add geometry where the actual triangle doesn't have it, which, it doesn't affect the geometry really, but it affects how it interacts with lighting, for instance. And there are other kinds of, I didn't write down them all here, there are different types, but environment mapping is a common one where you can fake reflections and refraction. We also use textures for sprites where you want to have just render some image in the middle of your scene, for instance. And we have a type of object called materials that specifies how primitives are drawn. So if you have something with a particular material instance, that instance has a bunch of properties. You can set colors on it, textures, various types of textures, and the type of material you use affect how the objects respond to things like lighting and shadow. And the most typical material you would use is the mesh standard material that implements something called physically based rendering, which is a very modern rendering model for based on physically correct lighting model. That is what normal games use these days. It's a bit more computationally intensive than some of the simpler models, like the Phong lighting models, which we also have. These are kind of old school, artificial, a bit plasticky looking lighting styles, but they have their place in certain things. If you want that look, those are nice to have. And then we have geometry, which is basically vectors of position. So we have a geometry defines a set of points, and each point also has additional information that apply to that point. So you can have a color for each point, you can have a normal at each point, you can have coordinates for the texture mapping, and then you take this data and upload it to the GPU, and then you interpret it depending on what kind of object you're rendering. The most typical interpretation would be every 3 pixels, or every 3 vertices are the corners of a triangle, and then you draw a triangle. And the geometry data is actually really extensible. You can add your own kind of attributes that you can then write shaders to access your own properties for whatever thing you want to do with it. And the most common thing to use to render these is the mesh. As I said before, it's basically a geometry plus a material, and it automatically interprets the geometry as a bunch of triangles, and it can fill them or draw them in wireframe. And in most cases, meshes is all you have, right? And they go from really simple things like we have a bunch of primitives for generating box geometries or sphere geometries, and you can put those in the mesh with a material, and then you render a simple primitive, and then you could add multiple of those. But it's more common to have a more complex mesh, like an entire enemy in a game, or the player or something, or even as large as an entire level. It's actually nice to have as large meshes as possible rather than having multiple meshes, because you will be able to upload the entire thing to the GPU and then have the GPU render it in parallel, which is much faster than doing it on the CPU. You should strive to have large meshes, or a few large meshes, basically. And there are, as I said, functions to create these really simple primitives, but normally what you do is you use a 3D editor like Blender to render or to describe your model and do all sorts of modeling and editing of textures and whatnot, and then you export it to this file format called glTF, of which we have a loader. That's a Kronos group defined format. The Kronos group is the people who define the OpenGL spec. So this is a very widely supported format. It's in JSON for the structure and binary arrays for the vertex data. We can have textures as separate like JPEG files on the side, or they can be embedded in the glTF format. And it's a very featureful format, has everything including animations and stuff, so it really can touch almost all the features of GThree from a single file. So it's very flexible, and as I said, widely available. There's a built-in plugin, or there's built-in exporter in Blender, and I guess every other 3D tool you can imagine. And it's kind of boring to list all the APIs, so I'm going to do a bunch of demos instead, because I think that's a much better way to describe these things. But we have all sorts of features. There's an animation framework where we can define keyframes, and it will automatically animate or interpret between the keyframes, and we can trigger actions. And when the actions are done, they can stop or trigger other actions or loop. It's very flexible. We have a skeletal animation system where we can define a skeleton for your mesh, which kind of is a simplified version of your mesh that is connected to it. So when you move the skeleton, you move the mesh around, which is a simple way to make character animations and things like that. We have an effect stack with some built-in simple effects, but also a very easy way to add your own if you write some GLSL code, and we have all the infrastructure to just plug that into your rendering system and apply some effect. And we also have like shader materials where you can basically dump some GLSL data, and we texture based on the output of that, which is very, very flexible. If you ever like played with the Shader Toy website, it's kind of like that. We can just do all sorts of stuff in a shader. We also have ray casting support. It's used for if you want to click on something and you throw a ray into your scene and see which object are hit. So it's the basis for basically mapping the mouse into the 3D space in a way that allows you to modify or interact with the 3D scene. And more complicated things, like we can render scenes to textures, and then you can use those textures when you render the scene again. So you can like fake mirrors and all these other kind of tricks you do in 3D. But as I said before, much more interesting if we do some demos. I think I'm going to stop that and so here it's a bit janky, I guess, over this stream, but here's a simple demo of a cube. It's got semi-transparent triangles and some lines, and you could probably, if you wanted, implement this in some kind of raw OpenGL, but it wouldn't be fun. Whereas this is just a couple of lines of code in GThree. And if you just wanted like a spinning cube in the about dialog or something, the level of dependencies this adds on top of OpenGL itself is very small. So it's not like importing an entire game engine into your app. It's just a small dependency, and you can easily get something like this. Not super interesting though. I get to the more complex stuff. Here's a example of what you can do with these are all the same geometry, but they apply different materials. And then some of the materials have like textures, and some are wireframe or have per vertex or per face colors in the geometry. So it's more like a demo of what you can do. Here's a demo of environment mapping, which is a way to fake reflections and refractions. The middle one is a refraction, so it's like a glass sphere, magnifying glass or something. And you can tell these are fake because the reflections aren't actually like they're not reflecting the other objects. They're just reflecting from the reflection map, which is also set as the background, as a 3D texture in the background. But I mean, for certain things, this is very much all you need. And if you really wanted, you could render the entire scene into a cube map first, and then apply that if you want to have the real reflections. But that's a lot more work. Here are some of the primitives we have for simple primitives that you might want to use. The white things are the normals, and you can see from the texture the UV mapping of the texture. Here's a single scene with 3 cameras, so you can sort of view the same scene in multiple ways if you want to do a 3D editor or something like that. Here's a sample glTF model from the glTF sample. They have like a GitHub repository with a bunch of sample models. You can see all sorts of cool things like partially reflecting, metallic, rusty things. These all reflect the environment map. So you set different maps, you get different kinds of reflections. Pretty cool. So this looks pretty cool, but it's really a simple model. You can have more complicated ones too. For example, here's a more cartoonish style where we have keyframe animations in it. So this is still using the physically based modeling material, but it's just done in a way that looks more cartoonish. It's pretty cool. This is just something I downloaded off the internet, but it's a pretty nice model. We have support for something called decals or decals or whatever, which is where you project a texture map on top of an existing geometry to kind of make a project a decal on top of something. It's commonly used in games, for instance, if you want to have bullet holes in your walls, or you want to add extra. Oh, if you have a large scale texture and you want to add extra, like small scale details, you can use these. It's pretty cool. Here's an example of the skeleton animation. So this model, so it really looks like this, the model. And the green and blue things are the bones in the skeleton. And then there's a set of animations that apply to the skeleton. So we can enable
2 minutes left.
Animation, for instance, and it will slowly move, and then we can crossfade to a different animation to get smooth animations, changes between animations. Well, smooth, it's probably not smooth on this stream, but it is if you run it locally. We have shadows, colored lights, shaders that run, and texture stuff. This is just a bunch of each one runs a bit of GLSL code that generates the textures. And sprites are more like 2D billboards in 3D space. And we have a point primitive, which is cloud of points. It's more interesting if you use particle effects, like you can use it to create fire and smoke and things like that. We have an effect system where you can stack various effects on top of each other and enable and disable them.
1 minute left.
And interactions where you can point at things. We have a cartoon material if you want to have a more non-physical thing. I wrote a game using this, or I ported an existing game. And I created a Wanda Easter egg I want to add somewhere. So I guess that was all the slides. And I really think people should look at this and see if you can add some cool 3D stuff in GNOME. Maybe we can add some Easter eggs, or maybe we can add some natural place where we can add 3D effects in the desktop. That would be cool. But I guess that's the entire slide, and I'm gonna look at the questions and see if anyone has any questions. All right. Do there exist tools to convert to glTF? My old code that I'm updating reads from .mdl and .md3 files, for instance. I'm not aware of exactly what those formats are, but I'm pretty sure that you can find converters for almost everything into glTF, because it's such a widely deployed format. If you can import your stuff into if you can import it into Blender, for instance, or 3D Studio, or whatever kind of 3D editor, I'm sure you can export to glTF. It's really common. And can we have some 3D Easter eggs? Yes, I think so. I want to add the 1.1 somewhere, but we can probably have others too. That would be pretty cool. I really do want to have some other kind of use in the of 3D in the desktop, but I couldn't really find any good places where it would make sense in the core desktop. There wasn't really any places where we could put 3D stuff. Yeah, so here's a question. Wasn't there a Doom kill thing at some point? Yeah, I remember someone actually modded the real Doom, I think, where they imported all the processes as enemies, and if you shoot an enemy, it killed that process. So I don't think that's necessarily a great UI for killing processes, but it was probably fun. Yeah, I mean, so there's another question of using this for the shell itself, for 3D effects in the shells. I don't know if that's really possible, because the shell renders in a completely different way, and it's kind of hard to inject GThree into the shell. And then it's a question about language bindings. I mean, I wouldn't say perfectly introspectable. We probably lack some properties for some things. But if someone starts using it for any the object introspectable language and finds some things that they would like to set that isn't possible, it should be easy to just add properties that are required for it.
So it looks it's all questions. And let's say thank you to Alexander, and we will be back at 17:45 with next presentation. Thank you, Alexander.
Thank you.